Good afternoon, everyone. How are you?
Hi, good afternoon, doctor. How are you?
Fine. So I was waiting that almost, I was hoping actually that many students will join today, but only 15 students and the class is of 31 students. So, okay, let's start the class. So today we are going to perform the first experiment. This experiment is divided into two sections because this is a little bit advanced topic, advanced course. So it will have two sections, simulation and hardware. So today we will perform the simulation, and in the next class we will perform the hardware. Okay, so we will divide this experiment in two 2 weeks. Okay, so first of all, if you go to Moodle, and did you see that the experiment is already available on the Moodle? Experiment number 1. If you go here, EE312, here in the lab experiments, the first experiment is already available. Okay, so just download this one, and you will see that it will open here. Actually, I already have it, so I can open it from here. So this is your first lab experiment. Here we will study the characteristics of bipolar junction transistor, BJT. Does anyone know what is BJT?
Bipolar junction transistor.
Yes. What does it do?
It consists of 3 terminals.
Yes.
Emitter, base, collector.
Yes.
It's construct of semiconductors. And we have
Silicon,
two types,
yes.
PN or
Semiconductors.
PNP. It depends on the
Yes.
configuration. And this
Yes.
device, it is, they call it current device because the current control the output.
Yes,
Input
that's
current
right.
control the output.
Output voltage, yes. So mostly we use it for switching purposes and also for amplification. Okay, so this is the BJT device, which has 3 terminals. So you see there's one rounded side and one is the flat surface. So if you move it the flat side towards you, then this will be emitter, this will be the collector, and this will be the this will be the base and this will be the collector. Okay, so it has 3 regions, and then one channel is in between the other 2 junctions. So this one is PNP and this one is NPN. Okay, so if we apply the voltage at the terminals of the BJT, if you consider this symbol, this will make it more clear to you. NPN. So for example, if I connect battery here, so this is negative, so this is base, and if I connect here positive, and that one negative, this is negative, this is positive, this is positive, this is negative. Now you see that this positive is connected with the N. It means this will be reverse biased, and then now here negative is connected with negative, so this one will be forward biased. Okay, we will consider these configurations because these configurations are important for to study different characteristics and to get different functionality from the BJT. Okay, so there are 3 regions of BJT where it can operate: active region, cutoff, and saturation. In the last class, let me erase this one. In the last class, we have studied some graph like this. Okay, so this is cutoff, this is active region, and this is saturation. Okay. So these regions are important because they will decide what kind of functionality we expect we can get from BJT. So then we can connect the BJT in different modes, which are common base, common emitter, common collector. Okay. So this, which I was explaining you, this one, for example, this is NPN. So if we connect this one forward bias, negative will be here, this one. And then this one, here if we connect positive, here negative. So this is common base or common base configuration. Okay, because base is common between emitter and collector. So there are three different type of characteristics of transistor: input characteristics, output characteristics, and transfer characteristics, which these all three we will study today in this lab, and also we will simulate them, okay, to see different characteristics of BJT. So here in this lab we are going to study the common emitter characteristics, and for that the input characteristics will be VBE. We will give the base current and we will see the base emitter voltage. So from in the output we will check collector current by giving VCE collector emitter voltage. Okay, so these are the input characteristics. Here this is the voltage, here this is the base current, and then on this the VC, if we give different values of VCE, then we will see that base current will rise exponentially. If we will increase the VCE, then the current will start to decrease a little bit. But the behavior of input characteristics is like this. And for the output characteristics, let me put it this side. So we will see that how collector current changes with different values of base current, IB base current. Okay, and then here VCE, we will be changing VCE here. Okay, then so these are the simulation results of your lab. So if you go to the lab sheet here, if you go to the first experiment, this one, yes, here BJT circuit for input characteristics. So let me open it. First of all, we will study the input characteristics of BJT. So this is the circuit. We have 12 volt of DC power supply. We have 1 kilo ohm of resistor. We have 200 ohm of resistor, and then VCE we will provide 12 volt, and this is the BJT. So I show you, first of all, you will go here, place source. Then can you open this software? Do you have it already in your devices? Do you have it already in your devices? In your laptop?
Yes.
Okay, please open it. Please open multisim. If in you press the Windows button here, you can write multisim. So this app, NI multisim 14.2. This one. Can you see my screen?
Yes.
So if you go here, place source. So first of all, you need a DC power source, 2 DC power sources. So this one, you will click it here, and then again this window will open, and then you will get 2 DC power sources. Then what we need? We need a ground. So from here, you will get a ground. Then you need resistor. So from the same, you will go to basic, and in the basic, go here resistor. So how much we need? 1K. So this is 1K. Okay. And then we need 200 ohm. 200, this one. And now what we need? We need BJT. So if you go here, transistors, and then here you have to write the number 2N3904. This BJT you need, so you will bring it here. Then you have to make the connections. How you will make connection? For example, you will put this one here. You
Miss?
will put this one. Yes. Yes.
Miss, we cannot use online multisim.
Online you can use, but it's better if we use this one, because in the next labs we will be using this offline multisim, so it has more characteristics and more features. So I recommend that you use this one. Okay.
Okay.
You have MacBook?
No.
Okay. So then when you come here, this dot will come, and when this dot is red, then this is a connection. Okay. Then you will take your BJT here. You will connect it with the base. This is the base. Then here, you will put this resistor here. Make connection like this. Here, and this one. Now my connection is complete. Okay, do you follow me?
Yes.
Okay, then when you are done with the connection, after that you will go here, simulate. Then analysis and simulation. Then you will go to DC sweep. Okay. Before that, it will be better if you double click this and you label it VBE, because this is base, this is emitter terminal. So this voltage is base emitter voltage, VBE. So name it here VBE. Then double click this one. And here, this is collector and emitter voltage. So CE, VCE. So just change this so that it will be easy for you to do the analysis. Then go to simulate analysis. Then go to DC sweep. And then from here, choose, because this one, this source one will be your x-axis. So let me annotate. So this one, source one. Here, source one will be here. Source one will be your x-axis. Okay. And then this one we will vary, but here we will check the base current. Okay. So this is important. Clear all drawings. Okay. Then from here you will tick this button, this one, and then from here you will select we will select VCE. Okay. Then select 2 volt is the starting value, and then 12 volt is the final value, and increment of 4. For this, 0 is the starting value, 2 is the final value, and 0.1 is the increment. Okay. You know that BJT gets very small signal at the base terminal, and then current starts to flow from collector to emitter. That's why the maximum value for this we are choosing is 2 volt. Okay. Then again, one more thing here. Okay. Then you will go to output. What will be our output? Base current. Okay. So from here you will select base current, IB. It will come here, and then you will save it. When you save it, you will just go here, you will run it. And then you see this curve you get. Okay. If you go here, this one, you can change the background, and from here, cursor, you check. So you see there are cursors here. And then here, this is VB. You double click this one, you know, this is VBE. And this is current IB. Okay, this one here. So you see that there is for the VCE 2 volt, VCE 6 volt, and VCE 10 volt. So what you will do is you will move your cursor according to the data sheet. So if you go down here, so for VCE 2 volts, you will check how much is the base current. So you will move your cursor, and then from here you can check this. This is the second cursor. So we will check here for 2 volt Actually, this is. So if you just deselect this 2, okay, now this is VCE 2 volt, okay, and now you will check if VBE is 0.1, how much is the current? So let's check where is 0.1. So this is cursor 2. So I think this should be 0.1. No, this is a bit, I will. Okay. Almost here. A bit, this is a bit higher. So 0.1. So this is 104 millivolt. It means that this is 0.1 volt. Okay, shift the decimal towards this point. 0.1 volt. How much is the current? This is minus 2.29 pico ampere. Similarly, you will change it to 0.2. So change it to 0.2.
Miss, how I will know this is 0.1?
See here, if you go here, this is 0.9. Yes, now almost here. So you see this is 106 millivolt. If you shift this decimal towards this, then this milli will disappear. So this is 0.1. 0.1 here. So here, can you see this window, cursor window? So this is 0.1, and then current is minus 2.257 pico ampere. Okay, then change it to 0.2. Now when, yeah, almost this a little bit high, a little, okay, yeah, this is almost 0.2. 0.2. So how much is the current? 1.04 pico ampere. Similarly, you will change it according to this. Let's check 1.3. Where is 1.3? Then you will see the current value will rise. Okay, now, okay, let me, when you have this kind of, yeah, this now again, where we want 1.3. Yes, this is almost 1.3, right? So how much is the current? 578.72 micro ampere. So similarly, you will change this cursor. So then you will see that, and then you will fill the table here, ampere. Then what you will do, now we have to check for VCE 6 volt. So this is 6 volt, cross this and then move, check this one. Then same steps you will do for this, and then you will fill the values here. Then you will check for 10 volt. So you will cross this, check this one. Then check, change it, and then check the values. Click, put the values here. Then check all of these, and then now let's, okay. Now go here, edit, copy graph, copy it, and then put it here in this box. Control V. So this is here. So this is the transfer characteristics, input characteristics of BJT. Did you understand this? Okay. Is it clear? Is it clear to all of you?
Yes, Miss.
Okay. Now we will see the output characteristics of BJT. Here I have already done. So these are input, this is output characteristics. So this part we are done. Okay. And table, I show you how to fill the table. Now we are going to check the output characteristics of BJT, and then we will see this graph. Okay. So everything is written in the lab sheet also. So what you will do is, In the same experiment, replace this one with this current source, okay, DC current source. What you will do is go here, control signal current sources, and then here DC current source, this one, bring it here, and then just connect it here. Actually, I don't want to I don't want to change the circuit, so I have already done it. Output characteristics. So now I changed the current source, signal current, and then DC current source from here, and then I put it here. Then what I do is I will change its value, this title to base current. This is base current. What we will check? We will check the output characteristics, and what is in the output characteristics? VCE. We will change VCE, collector emitter voltage, and we will see the collector current. Okay. So same thing. Make the circuit go here. So VCE we will vary from 0 to 2 volt. Okay, and then we will check the current. Okay. So if you go here, so we will check the collector current at the output. Okay. So if I run it, so yes, this one. So we have lots of values for it. Now again, I will click this one, and then now what is in the question? So the question is saying that for IB is equal to 10 microampere. Okay. So here IB is, so this is 1.2, this is 10 microampere. So we will uncheck all of these, uncheck. Only we are left with 10 microampere. We will check how much is the collector current when VCE is 0. For 0, it should be 0. Let's take the cursors from here. Okay, for 0, it should be 0. And then change it to 0.4. Okay, easy. So for me, check this. This is almost 0.4. 397. Almost 0.4 here. So how much is the current? Tell me. Anyone, please tell me how much is the current at 0.4 IB value? At 0.4 VCE voltage. How much is the current, collector current? Tell me, anyone?
1.1138
yes,
milli.
yes, yes, exactly. You will put this 1.113 here. So 0.4, 1.113 milliampere. Okay. Similarly, next is which value? 0.8. Let's check how much at 0.8 is almost here. So it didn't go there. Okay, 1 minute. Yeah. 0.8, almost, yes. 0.799, almost 0.8. How much is the current? 1.378. So we will put 1.378, 1.378. Okay, so similarly, next we will check for IB equals to 12 microampere. Okay, so this is 12 microampere. We will check this one, and then we will close this one. Now 1.2 into e raised power minus 5 means 12 microampere. For this, we will check the same 0.1, 0.4, and then we will write these values here in the table. So similarly for 14, for 16, we will do it, and then I will go here, edit, copy graph, and then I will paste it here, right? So this is the the graph should be should contain all these numbers, all these base current values. So
Miss, you mean 5 paragraph we put?
yes, all of them. Yes, these all of them. So you will go here, copy, and then you will put them here, this one. Okay. So I will tell you another trick to if you don't want to manually see these values, because it's difficult to check with cursor one by one. So if you go here, export to Excel. So if you export Excel, so check all of them and then okay. So this will make an Excel sheet for you. Now from here, you can see that all the values are here. What you have to do is delete this one, because I just need the y-axis values. Delete this one, then you delete this one, then you delete this one. Okay, now you have this is x-axis, and now you have all the collector current values for these respected VCE values. What you do is now select all of them, go here, insert. This is for your understanding. So actually one by one. See here. And then if I just select this graph, now these are the output characteristics of BJT. Okay. So these tricks, they are really very beneficial for you. You will use them. Either you can get these values from the cursor, or you can just get from here. Okay, this is for your understanding. So if you see that this graph is almost like this one. Okay, is it similar? Almost. You see that we get this graph by simulation, and it's almost here. Now we are done with this. Does anyone have any questions? Anyone?
Yes, Miss.
Yes.
Miss, this multi-sim, it's the same, the old one we use it already, or it's different?
Yeah. I used it. Did you take any of my lectures in the previous class?
Sorry?
In the previous semester, did you took my lectures?
No.
No. Okay. So this multisim is the same one. This is if you have already done some labs of 112 or 101. So this is the same software. Okay.
Okay, Miss.
So any questions, anyone, please ask me, because this lecture is very important. So then, if everything is clear, I will move to the next one. Now here, this was the input characteristics, this was the output, and now this is the transfer characteristics of BJT. So here we will see the input versus the output characteristics together. Okay. So our transfer characteristics is a graph that shows us the relationship between two quantities, both input and the output. Okay. What we will do is, so here we will, according to the data, according to your lab sheet, we will modify this circuit. Here we will have the same 12 volt. It's up to you. You use it 12 volt or 2 volt, because here we will always give very small voltage or current at the base. Okay, so 2 volt is enough. So then we have a BJT, we have resistor. So everything, and according to this, we will everything is written here. According to this, we will change the values and we will see the transfer characteristics. So if you go here, simulate, analysis and simulation. Okay, so VBE. Now you know that this, where this axis will come, VBE. Tell me, source 1, if it is source 1, so which axis? Horizontal or vertical? Anyone? So this will be the horizontal axis, I just told you. Okay, so then change the value, start value should be the 0, the final value should be 2, and increment 0.1. So then check this button. So this is collector emitter voltage 2 to 12 volt, and then increment of 4. So from here we are checking. So if you go back to the slides, so see here will be the output characteristics, collector emitter, and here it will be the input. So both of these are the voltage characteristics. So if you go here, so here you will see output should be So this is input, sorry, this is input. So this is the circuit. Okay, so if you go to simulation here, then here out, for this you don't have to check this second source. Okay, so for the output you will select V4. Okay, so this will be the base emitter, will be our base emitter. This one will be our horizontal axis, and output will be collector emitter output voltage. Okay, so if you run it, you will see this kind of graph. Okay, so can anyone tell me that which regions are these, which regions this graph shows? Tell me, anyone. So tell me, which region is this one? Which region is this one? And which region?
Left cutoff. Start with cutoff.
Yes, cutoff.
Then active.
Yes.
Then saturation.
Saturation. Yes. So if I clear all my drawings, so we can see. Okay. So from here, what does this data sheet shows? So now change the values of VBE. So VBE is on x-axis. Change the values 0.2 and then check how much is the collector emitter voltage. First of all, for 0 it should be 0.2. So from here select the cursors. So cursor is here. We have, okay, so this is the second cursor. So how much? 0.2. 0.1, yeah, almost, yeah, this 199 means almost 0.2, 0.199, 0.2. So how much is the collector emitter voltage? 12 volt.
12 volt.
We will write it here, 12. Then change it. For example, I will do this one, 1. Almost 1.01. Okay, this one is fine. So how much is the 4.77? I will write 4.77 here. Similarly, where should I put it? 2. Let's bring it to 2 volt here. Sorry, here almost, yeah, exactly 2 volts. This is 1.94. Yes, 1.94, and then you can get all these values by moving the cursor. And the second method is export it to Excel. So I have this. So my increment is very large. If I want to get exactly the how much is the increment for this, 0.146, 0.2 volt, this I can change so that I don't get this much difference. So go to simulate again, analysis. How much is my increment? 0.05. If I change it to 0.2, I will get exactly the same Excel sheet. So if I cross this one, because here the difference was more. Yes. Now if I export it to Excel, you will see this. You see now exactly the same table which is here. Did you see this? And almost, let's check the values which we checked. So at 2 volt it is 1.94. This was millivolt. So this is 0.19. So if I select this one, insert, go to graphs. So you see my graph is almost the same like this. Okay. So these are the 2 ways to check the characteristics of the getting the values in the table. Either you export it to Excel, or either you with the cursor you get the same results. So now this is it. And then here what you will do is either you put this graph. Okay. Yes, exactly. This was millivolt. So that's why it was 0.194. So if you go here, edit, copy graph, and put it here, this one. So this is it. So these are the transfer characteristics of BJT. And then for your understanding, I have plotted the graphs here and I put them here. And for you, it's fine. If you want to plot Excel, it's up to you. Or if you want to give me this graph in these boxes, it's up to you. I will appreciate if you put the Excel graph, but this is also okay. So this is it. And then this is all the simulation of the BJT. So in the next class, I will be, just a minute, just a second. So in the next class, I will be implementing the same circuit in hardware. Okay, so please be ready for that. And before that, one more thing, you should do it, because in the next class I don't want to give the demonstration for that. So if all of you go to onedrive.com, this one, and then sign in with your KCST ID. For example, your KCST ID is your student ID at the rate of KCST. So if you will put your Moodle password there, you will, this OneDrive will be active, and then you can save your work there, because in the lab we will be doing all of this. We will getting all these results from the hardware, and then we will compare them with our simulation. Okay.
Okay.
Clear?
Clear.
So please solve these three different characteristics of diode, not diode, BJT. I will be uploading these slides on the Moodle now, and please take reference from the slides, but don't copy my results. I want you to make your own results. Okay.
Okay.
And also for the next class, make you distribute yourself in three groups. Not three groups, 3 persons per group, so that you will be performing 3 people on one table, and then those 3 people will be, for all the semester, they will be the same. Okay, so that you 3 can share your work. Okay.
Okay.
Next class, tell me your group, discuss with yourself, and then. So any questions from today's lecture?
Clear.
Doctor,
Yes.
can you upload
Okay.
the record for today?
Yes, recording, I will upload it, and also these slides I will upload. But please remember, from the next, today actually I had some emergency, that's why the class is online. But from the next lab, all the class will be in campus, and there will be no recording. Okay.
Mhm.
And please do all this simulation yourself and bring the results. Actually, save your work in OneDrive here, so that you can compare your simulation results with the hardware results. And so yeah, that's it. So see you in the next class, and please all of you come to the campus in the next class next week. Okay.
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 Okay, Miss, thank you.
Thank you,
Thank
Doctor.
you so much. Thank you. Bye bye.